Hello everyone, in today's video, we are going to talk about identity and inverse matrix. So what is an identity matrix? It is a square matrix, usually denoted by I, where the diagonal elements are 1 and the rest of the elements are 0. So we have this example, a 2 by 2 and another one, a 3 by 3. As you can see, the diagonal elements for both the matrices are 1 and the rest of the elements are 0. So note that the product of a matrix A, the identity matrix I, is A itself. Example, if we are going to multiply matrix A by its identity matrix I, it is equal to A itself. So let us have example number 1. Let's determine if this matrix is an identity matrix of 3, 2, 4, 6. In order to do so, first we are going to multiply 3, 2, 4, 6 by 1, 0, 0, 1. In multiplying this one, we are going to apply the concepts in multiplying two matrices that we learned in the past. So from here, we are going to have 3 times 1 plus 2 times 0. And then 3 times 0 plus 2 times 1. And we have 4 times 1 plus 6 times 0. And then 4 times 0 plus 6 times 1. Simplifying further, we get 3, 2, 4, and 6. Since 3, 2, 4, 6 is equal to the original matrix, therefore 1, 0, 0, 1 is an identity matrix of 3, 2, 4, 6. So once you multiply an identity matrix to a certain matrix, the product will be that certain matrix. So let us have example number 2. Let's determine if 0, 1, 1, 0 is an identity matrix of 3, 2, 4, 6. So in here, we are going to multiply the two matrices. So row times the column. So we have 3 times 0 plus 2 times 1. 3 times 1 plus 2 times 0. And then 4 times 0 plus 6 times 1. And then the last one, we have 4 times 1 plus 6 times 0. Simplifying further, we have 2, 3, 6, and 4. Since it is not equal to 3, 2, 4, 6, therefore 0, 1, 1, 0 is not an identity matrix of 3, 2, 4, 6. Now let us have example number 3. Let us express each of the following as a single matrix. So we are going to multiply 1, 0, 0, 1 times 8, negative 2, 6, 4 plus 1, 3, negative 5, negative 7. So from here, when we are going to multiply 1, 0, 0, 1 times 8, negative 2, 6, 4, it is equal to itself because it is an identity matrix of 8, negative 2, 6, 4 plus, copy the second matrix, 1, 3, negative 5, negative 7. Then we are going to add. So all the elements or the corresponding elements. So 8 plus 1, then negative 2 plus 3, 6 plus negative 5, then 4 plus negative 7. Simplifying further, we have the matrix 9, 1, 1, negative 3. So that's the single matrix of the given matrices. Now let us have example number 4. Same, express each of the following as a single matrix. So we are going to multiply 5, 4, 3, negative 4 times 1, 0, 0, 1 plus 1001 times -3, 9, 8, -2. So from here, we all know that 1001 is an identity matrix of the matrix 5, 4, 3, -4, as well as 1001 is an identity matrix of -3, 9, 8, -2. So the result is we are just going to add 5, 4, 3, -4 plus -3, 9, 8, -2. Now we are going to add the corresponding elements. So 5 plus -3, 4 plus 9, 3 plus 8, and then -4 plus -2. Simplifying further, we have 5 plus -3 is 2, 4 plus 9 is 13, 3 plus 8 is 11, and -4 plus -2 is -6. So we have 2, 13, 11, -6. Now let's move on to inverse matrix. So given 2 by 2 matrices, A and B, and AB is equal to BA is equal to I, then B is called the inverse matrix of A, and it is denoted as A to the -1. A is also the inverse matrix of B. So if ever that we are going to multiply matrix A and its inverse matrix, it is equal to the identity matrix, or to its identity matrix. So in order to understand this one, let us have some examples. So let us have example number 1. Let's determine if -2, 1, 9, -5 is an inverse matrix of 2, 9, 1, 5. So from here, we are going to multiply the two matrices. And in multiplying, it is row times the column. So we have 2 times -2 plus 9 times 9, then 2 times 1 plus 9 times -5, then 1 times -2 plus 5 times 9, and 1 times 1 plus 5 times -5. Simplifying further, we have 77, -43, 43, and -24. Since it is not equal to its identity matrix 1001, therefore -2, 1, 9, -5 is not an inverse matrix of 2, 9, 1, 5. Now let's move on to example number 2. Let's determine if 5, -9, -1, 2 is an inverse matrix of 2, 9, 1, 5. So in here, we are going to multiply the two matrices. And take note, as we multiply, it is row times the column. So we have 2 times 5 plus 9 times -1. 2 times -9 plus 9 times 2. 1 times 5 plus 5 times -1. 1 times -9 plus 5 times 2. Now, let us simplify. So it is equal to 1, 0, 0, 1. Because 10 plus -9 is 1. -18 plus 18 is 0. 5 plus -5 is 0. -9 plus 10 is 1. So therefore, 5, -9, -1, 2 is an inverse matrix of 2, 9, 1, 5. Now let us find the inverse matrix of a 2 by 2 matrix. So if A is equal to A, B, C, D, then the inverse matrix of A to the -1, or the inverse of A, is given by the formula below. So the inverse of A is equal to 1 over AD minus BC times D -B -C A. So this is the pattern where AD minus BC should not be equal to 0, because once it is equal to 0, then we have undefined. So AD minus BC is known as the determinant of matrix A. If the determinant AD minus BC equals 0, then the inverse matrix of A does not exist or undefined. Now let us have example number 1. Let us find the inverse matrix of the following matrix. So given that matrix A is equal to 5, 2, 7, 3, so first we are going to identify our A, B, C, D. It is very important to identify so that we can substitute it properly later on. So A equals 5, B equals 2, C equals 7, and D equals 3. So the inverse of A, or A to the negative 1, equals 1 over AD minus BC times D negative B negative C A. Now we are going to substitute the values. In substituting the values, be very careful. So we have 5 times 3 minus 2 times 7 times 3 negative 2 negative 7 5. So from here, simplifying further, we have 15 minus 14 times 3 negative 2 negative 7 5. And then 15 minus 14 is 1. So we have 3 negative 2 negative 7 5 times 1, which is equal to 3 negative 2 negative 7 5. So therefore the inverse of matrix A is equal to 3 negative 2 negative 7 5. So let us have example number 2. Let us find out what's the inverse matrix of matrix B equals 6, 8, 2, 3. The first step that we are going to do is to identify your A, B, C, D. So A equals 6, B equals 8, C equals 2, and D equals 3. From here, we are going to have the formula for the inverse matrix. So B to the negative 1 equals 1 over AD minus BC times D negative B negative C A. So the formula is just a matter of remembering, okay? And then we are going to substitute the values. In substituting the values, be very careful. So 1 over 6 times 3 minus 8 times 2 times 3 negative 8 negative 2 6. From here, we have 1 over 18 minus 16 times 3 negative 8 negative 2 6. And then we are going to simplify. 18 minus 16 is 2. So we have 1 half times 3 negative 8 negative 2 6. Simplifying further, we have 1 half times 3 is 3 over 2. 1 half times negative 8 is negative 4. 1 half times negative 2 is negative 1. And 1 half of 6 is 3. So therefore, the inverse of matrix B equals 6, 8, 2, 3 is 3 over 2, negative 4, negative 1, 3. So let us have example number 3. Given that 9, negative 4, 4, negative 2 times a certain matrix X is equal to 1, 0, 0, 1. We all know that 1, 0, 0, 1 is the identity matrix of 9, negative 4, 4, negative 2. So therefore, to find matrix X, we are going to use the formula in finding the inverse matrix, because we all know that if a certain matrix is to be multiplied by its inverse matrix, it is equal to its identity matrix. So X is equal to 1 over AD minus BC times D negative B negative CA, or the formula for finding the inverse matrix. And substituting all the values, we have 1 over 9 times negative 2 minus negative 4 times 4 times negative 2, 4, negative 4, 9. So in here, we shall have 1 over negative 18 plus 16 times negative 2, 4, negative 4, 9. Simplifying further, negative 18 plus 16 is equal to negative 2, so we have negative 1 half times negative 2, 4, negative 4, 9. Simplifying further, we have negative 1 half times negative 2 is 1. Negative 1 half times 4 is negative 2. Negative 1 half times negative 4 is positive 2. And negative 1 half times 9 is negative 9 over 2. So matrix X is the inverse of 9, negative 4, 4, negative 2. If we are going to multiply it, it is equal to 1, 0, 0, 1. So that's it for now. Thank you for watching. See you again next time. Bye.